Hello everyone, welcome to the new episode of Micro Talks. Today we will be discussing another method of the direct microscopic count, that is the breeds count. In the last episode we had discussed the use of hemocytometer for a direct microscopic count. The breeds count has been designed by the American biologist Robert Breed. It is designed to enumerate bacteria, yeast and algal cells from samples such as broth culture, milk, water, beer, fruit juice and so on. This method can enumerate both viable and non-viable cells. It is a direct cell count and is done by a direct microscopic examination. A known volume of sample is spread evenly on a designed area on the slide. It is fixed, stained using a suitable dye. The average number of microorganisms are then counted per microscopic field. Let us look at what the requirements for this particular experiment are. You need a clean, grease-free glass slide. The glass slide has to be grease-free completely so as to prevent clumping of the sample. If the slide is not grease-free, then the sample will not spread evenly on the smear. You need a microscopic micrometer stage slide, dyes like crystal violet or alcoholic methylene blue, microscope with an oil immersion lens, and of course the cedar wood oil. How do you perform this particular experiment? What is the procedure? To begin with, we have to determine the radius of the microscopic field so as to be able to calculate the area of the microscopic field. The radius is determined using the micrometer stage slide. Thereafter, on a clean grease-free glass slide, mark out a square having a dimension of 2 centimeters by 2 centimeters. Spread 0.01 ml of the culture on the marked square. Spread it evenly and allow to air dry within 5 minutes so as to prevent multiplication of bacteria. Fix it using alcohol. Do not heat fix, as the shape of the cells can get distorted, resulting probably in a wrong count. So you have to dip the slide in a trough containing alcohol for a couple of minutes to fix it. If using a milk sample, then dip the slide in a trough of xylol for 10 minutes so as to dissolve the fats. This will not only dissolve the fats but also help in fixing the smear. Stain with alcoholic methylene blue and observe under oil immersion lens. Single bacteria, chain or clumps of bacteria are counted as one cell. Take a count of the number of cells that you can observe under one microscopic field. Thereafter, refer to the Wilson's chart and count the appropriate number of microscopic fields. Now, what is a Wilson's chart? This is a useful tool in microbiology, especially for estimating cell concentrations in a liquid sample through DMC. This chart provides a quick reference for correlating the number of cells that are counted in a microscopic field to the total number of fields that have to be counted, so as to get an accurate concentration of cells in the volume of the sample. A microscopic field is the area of the field observed through the microscope, and it is measured by pi r square. So if you look at the Wilson's chart here, it gives you the average number of bacteria per field and the number of fields to be counted. So if you have 0 to 3 bacteria in one microscopic field, you should count 64 microscopic fields. If you have 4 to 6 bacteria per microscopic field, you should count 32 microscopic fields and so on. This is the Wilson's chart. which has to be used at the time of counting the cells. Now let us look at the micrometer stage slide. The micrometer stage slide is a graduated slide with etched divisions on it. As you can see here, there are 1 to 10 divisions that have been etched, and the distance between 0 to 1 is 1 millimeter, and the distance between two microscopic divisions is 0.1 millimeter. So area of the microscopic field, as we all know, is measured by pi r square, where r is the radius of the field. And when this micrometer stage slide is mounted under the microscope, the diameter of the field is measured with the help of the micrometer stage slide. You just have to count the number of divisions that are spanning the entire microscopic field. How do you determine the area of a microscopic field? With the help of the micrometer stage slide, you have to determine the diameter of the microscopic field. So you mount the microscopic stage slide under the oil immersion lens and count the number of divisions that span the entire field. This helps to determine the area of the field. So let the number of divisions that cover the microscopic field be equal to n. We know that the one division on the microscopic stage slide is 0.01 millimeters. So the diameter of the microscopic field will be equal to n multiplied by 0.01 millimeters, or n multiplied by 10 raised to minus 3 centimeters. So therefore the radius of the microscopic field will be n by 2 into 10 raised to minus 3 centimeters. Hence, you can calculate the area of the microscopic field, where you have pi r square. So pi multiplied by this radius, that is n by 2 into 10 raised to minus 3 centimeters square. So let the area of the microscopic field that we have counted is equal to a centimeter square. Let's see how we can make a final calculation to determine the number of cells in the given sample. So the average number of cells that are counted is equal to x. If you are counting in the first microscopic field, if you have counted 4 to 6 organisms, then as per Wilson's chart, we have to count 32 fields. If we have counted 7 to 12 organisms, then we have to count 16 fields, and so on. So depending on the number of fields that have been counted and the number of organisms per field, you have to take an average number of cells that are counted. So let the average number of cells counted be equal to x. Now we know that the area of one microscopic field, that is a centimeter square, has x number of cells. But the area that we have marked on our glass slide is 2 centimeter by 2 centimeter. So the area of the smear is 4 centimeter square. So 4 centimeter square will therefore have 4x upon a number of cells. Let us assume that that is equal to y cells. The volume of sample used is equal to 0.01 ml. The volume of sample that is used to prepare the smear, that is 0.01 ml. So 0.01 ml has got y number of cells. Therefore, 1 ml of the sample will have y into 10 raised to 2 number of cells. This is a very simple calculation. So 1 ml of the sample will have y into 10 raised to 2 cells. This is a very simple calculation of the breeds count. Let us look at the advantages and disadvantages of the breeds count. Obviously, the disadvantages are that it is a total count because it cannot differentiate between live and dead cells. And it will count every chain of cells as one cell. Every cluster of cells is counted as one cell. So therefore, the count is not a perfect count. The advantages are that it is a very rapid count. It is used in the dairy industry as a platform test to determine the microbial load of the milk rapidly. That's all for today in this episode of Microtalks. I hope you all enjoyed the video and understood the concept. Please do like, share and subscribe to my channel of Microtalks. Looking forward to bringing you the next episode of Microtalks. Thank you everybody.